All right. Happy Wednesday. I hope everybody's doing well. All right. So these next couple lessons are going to be on slope. Today, before we get into a lot of the slope, we're going to look back, and we've already done proportions. And a lot of what this slope is we're going to look at in the next couple lessons deals with proportions. It deals with comparing one thing to another. We've got our fractions back and all of that. So today what we're looking at is being able to graph and compare proportional relationships and interpreting the unit rate as the slope of the line. On Monday next week, I'm going to be checking these notes, so make sure that they are all filled out with everything that I do here in this video. Proportional relationship. We've talked about this. This is very similar to the proportions we've already done, where we can take and we can graph, we can make a table. Remember, a linear relationship is proportional when the ratio of y to x is constant. Remember how we talked about proportions as being a straight line going through zero and so forth. Okay, the way we're going to be looking at it is slope is this way. Slope, which is the letter M. When we see the letter M these next couple of lessons, we are talking about slope. And what slope is, it's the y's over the x's. It's our up and down over our left and right when we're on a graph. Okay, so we're going to be looking at it as the change in y values over the change in x values. And really, tomorrow we'll get into that even a little bit more in your other lesson that you're going to do. Okay, so an example is in this one here. Okay, this would be the equation y equals 3x, and what that means is the slope is 3, or 3 over 1. That means we're going up 3 because it's positive and right 1. But again, that'll make more sense when we get more to the slope thing. So don't worry about that too much right now. I just want to make sure that you have this information down in your notes. So make sure that's copied down. All right, let's read through this next part here together. An equation such as y equals 3x is called a linear equation. A linear equation is an equation with a graph that's a straight line. We've talked about that. The line has to be straight. That means it's proportional. That means that as the y is changing, the x is changing the same. Notice this equation also contains more than one variable. The solution of a linear equation consists of two numbers, one for each of the variables. And those variables are typically going to be your y, your x, and your y. And the numbers are the numbers that come in front of those. Those are the important ones. A rate of change is a rate that describes how one quantity changes in relation to another quantity. In a linear relationship, the rate of change between any two quantities is the same or it's constant. This is called the constant rate of change. And we're going to look at that. In proportional relationships, the unit rate, we've seen unit rate before, right? Per 1 is the slope of the line. We want, basically, the slope is going to be the fraction in its simplest form. Slope is the rate of change between any 2 points that are on our line. Now, with any of these problems, the easiest way to help better understand this is to look at some examples. So take a look here at this first one that we have here, this example 1. We're going to find and interpret the slope here. So to find the slope, we find the constant rate of change. So we need to pick any 2 points on this graph in order to do that. So let's use these two. Let's use 115 and 230. Okay, so this is over 1 and up 15 for the first one. Remember, when we do coordinates, they're xy, right? To find the slope, we're going to find the rate of change. So again, our change is going to be our change in savings. It's going to be our x's, or I'm sorry, our y's over our x's. I'm saying, what did it change from and to? So basically, what was the change between the two y's and the two x's? So when we look at this, when we look at the y's changed from the top one to the bottom one here, 30 minus 15. I'm looking at the difference in those. And then, so this is our savings, our money, and our x is our weeks. And our change in our x's was from 2 to 1. Since the 30 was first, I've got to put the 2 first here. So when we do that, 30 minus 15 is $15. That's the change in y. How much did it change going from that second one down the first one over the change in x's? 2 minus 1 is 1. So that's part A. Part B is find the unit rate. Well, it's 15 what? $15 per week. That is the unit rate, and that's how it compares to the slope here. For every one we go across to the right, we're going up 15. So we're going from here to here, we're going up 15, and right 1. Then we go up 15 and right 1. Then we go up 15 and right 1. And that's what's keeping us on that line here. That's what that is. So pause this video and try the check. Do the same thing we just did. Pause the video, try it, and then come back and watch. All right, so hopefully you paused there and then you came back to watch the check here. So again, let's do the same thing. Let's just take these first two here. And we're going to do our y's over our x's. So our inches is the y's, and feet is the x's. So what's our change in y's? In y's, we went from 24 to 12. So we're going to do 24 minus 12. And our x's, we went from 2 to 1, 2 minus 1. So our change in our y's, the last numbers, 24 minus 12, change in our x's. 24 minus 12 is 12, so that's 12 inches. And 2 minus 1 is 1 in 1 foot. 12 inches per foot. Well, that's what a foot is, right? 12 inches. All right, let's go to example 2. All right, example 2. Graphing this equation, the number of times y, a honeybee, can beat its wings. So y is how many times it can beat its wings in seconds, x. So x is our seconds here, is proportional. The situation can be represented by y equals 200x. Graph the equation. So first we got to make a little table here. So if it's every y is 200x, if I make my table, and we have our x's, oops, I erased it. We have our x's, we have our y equals 200x, and we have our y's. So if our x is 0, our x is 1, our x is 2, we're going to plug that in and say, well, what does y equal? Well, in this first one, y would be 200 times 0, which is 0. For when x is 1, that'd be y equals 200 times 1, which is 200. Here, for this one, we'd have y equals 200 times 2. We replace the x with the x value, and that would be 400. So that means one of our spots is 0, 0. Then we got 1, 200. And then we got 2, 400. Okay, so all right, so we graph those. So that would be 0, 0, 1, 200. This is in hundreds, so the 2 means 200. And 2, 400. And so this right here would be our line going up there. That's part A, making the graph. And then part B, what does that mean? Well, the key one is this one. We want the one where the x is 1. That is kind of our slope. That is our interpretation of the slope, because that's telling me that it goes 200 beats per second. Wow, that's a lot of beats. A honeybee beats its wings 200 beats a second. So the one that matches up with there is D. The slope of the line is 200 over 1. This means the honeybee beats his wings 200 times per second. All right, a couple more here. Example 3, determining proportion. A manatee can swim an average of 10 miles every 2 hours. Assume the distance y in miles is proportional to the number of hours x the manatees swim. First, we're going to create our graph. So we know, let's see, distance is our y, right? And hours is here. So we know that it can swim 10 miles every 2 hours. Okay? So if I make this to be where it's just 1 on the bottom, I'm dividing by 2, right? So 10 miles I would divide by 2, and that would be 5 miles in 1 hour, right? If we were to double that, 4 hours, that would be, so that'd be times 2. So 10 times 2 is 20 miles. I can get several of these. So that means, like, for this one, that's the one I really want, it's 1.5. Here we got 2.10. Here we got 4.20. I just need about 3 good ones to make our line with. So we know we got 1.5. We got 2.10, and we got 4.20. I can also guess what 3 is, right? 3 would be 15. But that right there is going to be our line. Part B, we want the slope. So again, the easiest way to find slope here is just with the 1. And your assignment today, that's what they're going to be. We want to know when x is 1, what is y? So this is 5 miles per hour. So the slope, the m, is 5. Okay, that's always what it comes out to be, is what it is per 1. If we go back up here, this one would have a slope of 200 because it's per 1 second. Okay, up here, this would have a slope of 12 because it's 12 inches per 1 foot. Here we have a slope of 15 because it's $15 per 1 week. Okay, last one to look at, example 4 here. Y equals 1.5x, right? So let's take a look at this one. Make sure we understand what we're doing here. Represents the between the number of heartbeats, y, and the time in seconds. The graph shows the heartbeats for a cat, which has a faster heart rate. So in this one, right, this one would have with y equals 1.5x, that means it's 1.5 beats per second, right? And that is the one for the dog. Now we need to find the cat. So remember, we want 1. That's the one we want. So for cats, it's 2 beats per second. So it's asking which one has a faster heart rate. So which is faster, 1.5 beats per second or 2 beats per second? It would be the cat. Okay, now what you're going to do now that this is filled out, you've actually got 2 assignments to complete. The first one is to go into pair assessment. The link, if you go into our backpack and go to our pair assessment where we take some of our quizzes and tests, you're going to see an assignment in there that says 11.5. No, never mind that. You all